Hello, everyone. I'm welcome and thank you for joining us. I'm Guillermo Varela from McGill Europe, and I want to introduce today's speakers, Fernando Seña and Thomas Holt from Reope. They are both architects. Fernando is specialized in automating workflows for design and simulation analysis. And before joining Reope, he worked in the computational design departments of Grammatio Kohler at EHT Zurich and Mace Architects in New York. And Thomas is specialized in programming and worked as a consultant towards companies in the building industry using programming parallel to improve the efficiency and quality of architectural production. Today, they will present some of the tools they have developed for Reope's clients. And this includes Grasshopper and Rhino inside Revit workflows to automate data-driven designs focused on facades and urban developments. They will also show their plugin metrics for early-stage volumetric studies. They have prepared some example files that I will share in the chat and later in the recording of the webinar. Please remember that you can ask questions in the chat and we can answer them in the last 15 minutes of the webinar. And also that the webinar is being recorded and we'll upload it to YouTube tomorrow. Thank you again, Thomas and Fernando, for accepting our invitation. And please start with the presentation if you're ready.
Thanks to you.
Thank you.
So I'm going to share my screen. Can you see it?
Yes. Perfect.
Great. So, give me a second. Thank you, everybody, for joining. We are going to be talking about how we are using computational design and plugin development at Reope for different clients. In my case, I'm not showing live demos, but I provided all the samples, but Thomas will do a live demo of metrics, and I hope you enjoy it. So Reope is a company that is part of the Bad Monkeys network, and we are a company of architects and engineers who are specialized in coding, producing solutions for different clients in the AEC industry. And quite recently, there was another company that was created under the Bad Monkeys umbrella also here in Oslo, which is Anchor, that is specialized in data management for building construction. This is the whole team of Reope today. Here you have Igor, Thomas, Pele, Rita, and Dimitar, and myself. And we are going to be presenting two collaborations we have been developing in the past 2 years. One is OsloWorks, which is a company that is based in Oslo, quite recently founded, like 6 years ago, of around 24 employees. And the other one is the work that Thomas will present, which is what we have been doing for Heatherwick Studio, that I guess most of you know. It's based in London, an international company, and all that. Okay, so let's start. So I'm going to be showing you 4 projects that we developed for OsloWorks. And the first one is this, is Brakeroya, and it was a very interesting project because the work we did was kind of simple, and it was applied to a project that was very peculiar because it was a project that was not going to get built. So basically, they came to me and they told me, you know, we have this project, which is for a client whose land is going to get expropriated, and they needed to develop potential urban development to set a correct price for the land. And this is important because they had to develop a project that looked like it was a real project, but without putting all the effort that you will put on a real project, right? And basically, this meant that they had to draw all the exterior facades of the volumes that they had done for the volumetric studies. So basically, this is what I found. They told me, you have 2 weeks to populate this with facades, and these are all the designs that we are going to provide to you. And we don't have time to do it manually. We are kind of with a tight schedule. What do you think that we can do? So the first thing I suggested to them was, okay, we need to develop some kind of a strategy, like how you are going to apply these designs that you have kind of quickly created or whatever. Because we were not using, and this is a very important thing, we were not using any kind of artificial intelligence system. They were kind of reluctant to this. And you need to understand that they wanted the buildings to look like real buildings. So we couldn't just simply copy and paste a design. So we developed this kind of, well, I'm showing here 6, but probably there were more. I am not fully aware of the amount of them that we developed, because we developed a lot of them. So the first strategy was like, okay, you get the facade and you just simply subdivide it into whatever module it is, right? But then they wanted to include, the lower levels who have a different kind of design compared to the upper levels. But then, you know what? We actually want to combine the lower with the upper. Then, top levels, we would like to have a different kind of design. And you know what? In this case, we don't care so much about the designs, but we want to randomize the designs, right? So we developed some kind of generic strategies that could be applied to different designs. And in this last one, it's important. I'm only highlighting the sides, the corners, because we were treating this not as a script that you could literally apply to all the facades. We were treating this as a script that could be applied to different facades in the same volume for the building, so that they could customize every facade, and they could decide, okay, on the north facade, I want to have retail levels, but I don't want to have it in the south facade, or vice versa, whatever, right? So the last example is when we started to implement solutions for the corners, because until then, the corners had been left like, okay, you complete it manually, because we were in a kind of a tighter schedule. There was no time to think about everything. But at the end, we were able to start to implement solutions for that. So as you can see, these are 6 examples of the multiple designs that we developed. Each of them is like a different kind of a script. And they were able to play with different parameters. There's something you need to understand is that this project was mainly, this kind of workflow was going to be mainly used by people that didn't have a lot of experience with Grasshopper. In some cases, they have never used Grasshopper at all. And it had to be made in a way that it was easy for them to use it, right? So we developed a series of designs, each of them corresponded to a different script, based on the constraints that they have given me. And thanks to parameterizing that, as you can see, this is a very simple example of how you can use Grasshopper. They realize, okay, as everything is parameterized with the same script, we can actually create variations. Then we can enhance the design. Then it's not just simply a copy paste. Then it actually looks like a real building. And it was also very nice because this is showing that, okay, initially we were starting from a surface, but the reality is that with the script, they could grow the levels without actually modifying the initial surface, which was kind of great because at some point they realized, this building has to be higher. There is no need to change what you had in Rhino. You can simply change it in Grasshopper and make everything a little bit faster, right? So the good thing was, at some point they realized that as everything had been parameterized, they could create with the initial script, like, no, this is the design we gave you. But with the parameters, they realized, oh, we can actually make all the designs that are good enough to include it as different variations. By the way, I have to be honest, they only gave me these 2 other ones. I created them before the presentation. Doesn't mean that they did that. So if there is a design mistake, my fault, not them. So the thing is that this led us to the following question, which was, okay, these scripts are very easy to apply when you have a very simple extrusion, like a box, right? But what happens when you actually have this? Like, how is this going to happen? Because the script was not really prepared to respond to all these kind of geometric Boolean operations. Because actually, to be honest, in all these kind of different surfaces that compose the facades, they were actually playing with the distance of the module. So it doesn't mean that the large surface here was going to have the same kind of module that than the narrow one, right? So I created this kind of a script that, okay, you give me the module that only works if it's properly built, which was kind of great, because if there was a mistake, this was a way to avoid accumulating mistakes at the end, right? So it was, you had to provide a script, a perfect Boolean operation where everything had been joined and everything had no mistakes. And from there, you could extract the different kind of surfaces, that vertical surfaces that compose that facade. And then they could decide if they wanted to apply the same module in all the facade, in all the surfaces. To be honest, sometimes it was not so easy, because as these had been modeled by several people, there could be tiny differences, or someone could have decided something else, because, you know, it's architecture is what happens. So the thing is, this workflow or this process seems like a kind of very basic grasshopper thing, but it gave us a lot of information about how we could keep developing workflows with Oslo Works, right? So one of the most important things is that they realized that the way you storage you save the files in the server and the way you manage the file was extremely important. So there had to be a folder, basically, where you saved all the designs that you were looking for, the initial designs. And those designs were the designs that were going to be copied to the different projects that were going to be applied. Because the funny thing of this is that this is not an operation that they just use for this specific project. This is an operation that they were using in multiple projects for different kind of things. So the thing is, they copied the files, then they generated their own versions by themselves. At this point, I had no control over the script, like they were doing whatever they want. And the good thing was that at some point they realized, hey, you know, these variations that we are creating with initial scripts are kind of good. We really like this design, and it doesn't need to be specific to this project. We could save it in the main folder where we are keeping all these things. And keeping the folder, the initial folder clean and organized, it was very important, because it was the best way to say, okay, if 2 months later I want to apply this specific design to this specific project, if you had modified, that was kind of a problem. So then they realized they had to be a little bit more organized with this. Another thing, and I should have mentioned this, and I will mention this with an anecdote. This was a super fast process. We did this in 2 weeks. And the good thing was that in 2 weeks, I did the scripts, but I think when they actually used the scripts, they did it like in 2 mornings. And it was very funny, because the first day they told me, okay, I arrived to the office more or less at 9, and they told me, we need this by the end of lunchtime. I come from Spain. For us, the end of lunchtime is like 2:30, 3. In Norway, it's 12. So when I was thinking like, oh, I only have 3 hours. The funny thing is, maybe the first couple of iterations I was kind of suffering, but after the third one, we had created a template, and I could be way faster than any of them manually modeling everything. And the results were exponential, because even at some point when I had already given the scripts to them, they were creating their own variations. So everything was even faster. And finally, with this fast thing that we had to complete, there was a very important thing, which was, how do you present these scripts to someone that has never used Grasshopper? So I developed this kind of template where I was basically, okay, this top group is where you have the instructions of what you have to do. That is where you find all the information. Everything that is gray, don't pay attention to it. The only thing you need to touch is the pink area. Everything else is fine. And this was great because even people that I didn't even have to explain how the script worked. They could do it by themselves. They just open it and that's it. That was it. So that really helped to speed up the process. So the next project, Fornebu, which is an ocean campus, and it's a campus that has this kind of urban development area, but also has this kind of not so regular building. That is actually a rehabilitation center for marine life. And here you can see one of the first projects where they applying these scripts to generate facades when they had to do like a quick urban study. These facades don't correspond to the initial facades. They were developed much later. And actually this project has been developed with in collaboration with Haptic Architects. But the thing with this project is that the main concern was the shape of the rehabilitation center. So they came to me and they were like, okay, we have this shape. We have produced it more or less in Rhino, but we still have mistakes. We need actually to move it to Revit. I mean, actually the question was, how can I make this in Revit? And I was like, there's no way of making this in Revit. And okay, I was like, okay, you know what? We need to find a strategy for you to be able to modify everything without having to touch Grasshopper a lot or in a different way. So the idea that I developed, and this is completely based on a puffer fish component, thanks Michael Prior, was that we were going to create a graph mapper in the top view in Rhino, and that was going to change the final output of the floor plan. So the user only had to provide a control point curve that they could draw in any length they wanted, and then they had to provide the floor plan of the perimeter of the element, right? And by modifying the control point curves in Rhino, they were going to modify the final shape with Grasshopper. So this is basically the script, and you have it in samples. Here you see the component from Pufferfish, which is the curve graph mapper. And the only thing you need is you provide the control point curves and the floor plan projection of the hole or the perimeter, whatever it is. And that's it. I mean, maybe the only thing you need to check is maybe the length of the perimeter so that you can do a control point curves that has more or less the same length, so that when you control the points, everything kind of corresponds with the unfolded elevation of the building. But the thing is that at the end, we reduce the amount of inputs of the project to only these 9 inputs, which were, okay, in this case, for this floor plan, I need these 3 control point curves, and I need these 3 projections of the perimeter on the floor plan. And then I also need these kind of quick triangulations that they didn't even need to do, like a very difficult, I mean, you just simply went there on Rhino, you drew the triangle and that's it, to help build the surface later, right? And the thing is, as you can see here, by modifying the control point curves in the top view, you could modify the shape on the right. But one thing, you will notice that here, when you modify one control point curve, you don't see a lot of differences in the surface. This is because I also introduced some kind of limitations for the top height and bottom height, because otherwise, if it was completely free, as in this first example, they could kind of break the shape. So it was a kind of a constraint and making sure that you are going to get a shape that is okay. And this allows us to introduce not just control of the shape, but also control, for example, of the slope, because at the end, this was going to be a surface where people were going to be able to walk around and do whatever. And this allows us to, okay, you know, in these red areas, the inclination might be to be, you might need to reconsider this. And it's true that this script was used for the early stages of the design, and it was relatively successful. Now, next project, Vitamin Verein, an office building here in Oslo. Very interesting project. They basically came to me with this question. So we have the project in Revit, we have everything, but now we need to calculate the average height of the plot. So the average height of the plot, according to the Norwegian building code, is basically when you have drawn your building, you have to extract the new perimeter of the plot that you have created with your design. And what you have to do is you have to find the plane, horizontal plane, that cuts that perimeter so that it generates two surfaces, a top surface and a bottom surface, and in a way that both surfaces have the same height at the same area. And with that, you calculate the average height of the plot, which is super important because it's going to limit the top height of the building. And in some cases, if depending on the topography, this can mean one floor more or less. So the thing is that until then, they were feeling extremely uncomfortable doing this because the way they were doing it is they were selecting points in the perimeter and they were extracting the height of those points and they were kind of calculating the average of those points. But it was like, okay, how do you know that you are selecting the points in a way that is kind of relevant? Because maybe if you select all the points that are on one side, you are going to get a dimension that is not really correct. So I developed a script that initially it was going to work in the same way of what they were doing, which basically is you get the perimeter. By the way, the perimeter had to be done manually. There was no way of automating that, and that's why it was super important to have the architect who had been in charge of the design there, because in many cases there were exceptions that he was aware of it. Like there was, I mean, we try automating it with Boolean operations. No way. So the first method to calculate the average height was like, okay, we divide a curve in as many points as you want, and we get the average height of those points. And it was basically the same system that they were using before, but now all the points are distributed evenly. And this was working great already. And they realized, at some point, no matter how much you increase the points, you are always going to get a height that is perfect. Like this height was in millimeters, by the way. It was not going to change more than the final decimals. The thing is, with that, we created a script that was able to cut and create those two surfaces. So then they could use the initial surface that they had got from the kind of wrong method to calculate this, to iterate it in like 4 or 5 iterations, and then you could get a very nice result of the average height of the plot. And as you can see in the video, like, in the yellow part, in the top group, you have the height, whatever it is. You introduce it in the green square, and then you compare the areas, and then you will realize that at the end there was going to be only a difference of, in this case, 4 or 5 millimeters. It's not that big. So yeah, that was it. And all of a sudden, they were able to complete the process in the way they were supposed to complete it according to the code. And they were 100% sure that the result that they were getting was correct, which was the great thing. And all of a sudden, they were like, "Oh, this is a relief." All of a sudden, I'm in control of this. Okay, so last project I'm going to show you, Verbet Hotel in Tromsø, Norway. For this project, we developed a workflow that we have already been kind of checking for different projects before. So mainly they had in the projects, they had this requirement. For the people that don't know a lot about Revit, I will try to explain it in a way that they can understand. So when you have the project, you need to produce a document, which is called the legend for windows, for doors, where you basically are reporting all the types of windows that you have in the project. And the problem then was that they were using an add-in for Revit that it was working with some mistakes, but not fully working. And it was especially not working with, for example, if you were checking the windows and you had the windows in the main model, but then you also have windows in one of the links, you couldn't retrieve the information from the links with that. So I developed this Rhino Insight workflow to get both of them, the windows from the main model and the windows from the links. And as you can see here, the windows, the ones that are colored are the ones from the model, and the white ones are the ones from the link. And you can see like we have 10 here, and then I'll show here, which are the 12 ones we have in Rhino. So the huge advantage of this workflow was that thanks to Rhino Inside, all of a sudden, they could pre-visualize the legend in Rhino and make sure that whatever we're going to export to Revit was going to be the correct thing. Because this operation takes a lot of time. I mean, in this case, it's like a minute or so, but this is why I couldn't show it to you today. Like, I don't want to risk that this is going to take 1 or 2 minutes. But in a real project, you can imagine that it takes more. Like, I remember one example, it took like 10 minutes or 15. But the thing is, it also was taking 10 minutes with the add-in. But the huge advantage in this case is that you were already seeing what you were going to get in Revit. So it was like, okay, fine, I'm going to get it. So no problem. So the way this script works is like, first of all, we kind of filter out all the potential useless links that we don't need. Believe me, this can happen because if someone has unloaded a link in Revit and it's kind of missing there, we have to get rid of it from the reading. Then we get all the elements from main model and links and whatever. And then we say, okay, we only want the windows in this case, right? Then we need to check, because in the legend, you don't want to include all the windows. Maybe you only want to include all the windows that have this kind of opening or whatever, right? So when the script was providing, okay, you have these 2 windows, Alu, Tre, combination, double H, and then you have the single window. Which one do you want? I only want the Alu Tre, the other one I don't need it. Great. So now we have filtered all the windows that you actually need with their types, right? Now the question, the big one. When you get the legend, there were mainly 2 ways to organize the legend. So the main one, somehow my favorite, because it's the only one that doesn't create many issues, is to organize the different types of windows by a unique identifier number, which is called the type mark. This is the best because basically if you have window, I mean, in this case for this project, it was named with a Norwegian notation. So basically it was V, that stands for vinduet, which is window in English, and then a number. So basically you get the windows like B1, B2, B3, whatever, right? But there was also another possibility that the other add-in was offering, and therefore we copied in the script, which is like, okay, you know what? You order the windows by width, then by length, and then by the unique number, because of whatever design decision you need to take. And that's the 2 options I gave them with this script. By the way, if someone says like, hey, what the hell is going on? Usually when I see a merge component with so many inputs, it's like, oh, there's something wrong here. But no, in this case, it's because here you are getting all the potential parameters that you want to report in the legends. Like in this case, this was the name, width, height, number, type mark, and whatever. And this is it. The funny thing was, we couldn't do it with legend components, which is the way Revit will have done it. So we did it with detail lines. And this was great because all of a sudden, they were able to get the legend way faster without having to do many times the same operation. And with the detail lines, they were able to edit the graphic output. And that's one of the things that they care most about. Like, they wanted to introduce this and that and make it look nicer. And so this was a huge advantage with this. So conclusions, with all these 4 examples I've shown you. You have on one side the customized script for this kind of special project, like was the Fornebu project. And then you have this kind of generic scripts for this kind of more regular architecture that doesn't have such a geometric complexity. And yeah, I mean, the complex projects are very nice because they have a lot of high exposure and whatever, and they present to you with unconventional solutions. But then you have these generic scripts that they can be reused more times, which is great because you kind of make, I mean, the time invested in developing this becomes a better investment. And then you have more possibilities to improve them because you are exposing them to more cases. And therefore, they have a higher impact because it's not just for one project, whatever. And you actually can discuss this if it's worth, and it's a great way to test if this is worth transforming into an add-in or not. Actually, when we were preparing some material for today, yesterday we were discussing how we could improve how we could transform one of these into an add-in, particularly. So yeah, and I think that's done. It's time for Thomas to start.
Yeah, all right. Thanks, Fernando.
Wait, I have to unmute myself.
Yeah, you don't really have to do that. I think okay. I think it's fine. All right. All right. So let me just share my screen here. So share screen. Screen 2, there we go. So yeah, so I'm going to present Metrics, which is a Rhino plugin, which we have developed here at Reop. Here, several people here at Reop have been working on it. So it's not, yeah, so it's most of us have been into it, and it's developed for Hedderwick Studio in London. So in close collaboration with them, and it is, I can go into what it does. It's mainly, you know, as you will see it later, it's mainly built as a kind of enhancement of an existing workflow, which they had or have at Hedderwick, and we built a plugin around this, which facilitates this workflow for them, which is basically doing volumetric studies in early stage design, which I know many people used Rhino before. So, and during making this plugin, we also developed a few functions, for example, the parameters system alongside the scheduling system, which I believe can be used for other things, not just volumetric studies. And just a second here. And we developed it to be intuitive, easy to learn, like to have a lean learning curve. And as I mentioned, to kind of integrate into the already existing habits of the designer. And it's also integrated into the Rhino UI and the Rhino model and the Rhino objects. So, you know, any data will stay in the model. So I'm gonna quickly go through some basic functions in Metrics. And yeah, so it's a kind of basic introduction. It will not show everything, but a small set of items. I will do this live, so I hope things doesn't go completely wrong. So let's go. All right. So here I set up a simple model on a site. It's not a real project. It's just a something I made for this presentation. And so we're going to focus on the green buildings in this setting. So first I'm going to just mention a bit Metrics, which is now is in this panel here. And so everything which we have in Metrics is in the one single panel. And at the top, we will have this bar with a bunch of buttons, and they switch between different tabs or even open windows for the user. And we kind of made it, you know, like in this workflow perspective. So we kind of usually would start from the left and go to the right as you develop your project. So let me just see. So we can start on the left side, which is levels. So it's quite simple. So basically, I just select, you know, turn off this. Let me see. Select all the volumes, all the green volumes, and click create on levels, and enter a height, 2.5 meters maybe, and then there we have it, levels. And just for these levels, they can be edited. So I'm just gonna, for this example, I'm gonna move all the levels except the ground floor up a meter to say that we have a higher ground floor, which is not so uncommon. So there you go, simple as that. So just for the example, I'm gonna just hide a bit of the context. You see more what's going on. So, and then next step would be a short introduction to the parameters, which is located here. So, yeah. So as you look in the UI, we have a bunch of parameters here. I made a few of them. These are the parameter definitions, which we can assign to the objects, the Rhino objects. So I'm just going to show by example. So just going to show how to create a new parameter. And I'm just going to create a function parameter, which is going to be a category. I'll go into the different parameter types after this. I'm not going to create 3 different categories. I'm going to call them housing, retail, and office, for example. Save. There you go. So now I have this category parameter. I will assign this parameter to the objects by selecting them. I can maybe go here and select them like this, and I click the function and assign it. And as maybe in a typical project, you would assign different, you would, change the value of this parameter according to whatever function you have. So I'm going to put on the display color, which will show the colors of this category parameter into the in the model. So if I change these buildings here to be, for example, to housing, they should change immediately to reflect whatever function I have. So now, I showed a bit how the parameters can be added. I'm just going to mention we have several parameter types. I showed the category parameter, which is a way to you can classify objects, you can assign different categories. It can be as many as you want. You also have all the types of parameters. The simple text parameter, which can be any kind of text you can assign to something. A number parameter, which is basically a simple number. You can add units to it, and you can use them in a formula. I have the category parameter, which I showed you already, and you have the formula parameter, which can be quite useful. You can kind of do any kind of parameter, any kind of formula in it, fetching data from either geometry or number parameters, and the geometry parameters is then extracting geometric values from the actual geometry in Rhino. So such as area for a floor surface, or a volume for a building, or curve length, and whatnot. Right. So let's see if I covered everything here. Yeah. So next step would be I want to show you quickly the formula parameters because they're quite cool. So I already created one. I can just show you how it looks. It's just basically, in this example, I wanted to, for example, maybe you want to you probably do it a bit more advanced in a real life example, but say you have a square meter price for example, rent, and you can multiply it by the area of a floor, and then you would have the price of that floor for yearly rent or something like this. So this is and so this is a simple formula, and this square meter price is referring to another number parameter which I added from before, and I can show you a bit later how that can be used in Grasshopper, for example. So yeah, again, total price parameter, you have square meter price multiplied by area, and those square meter price is this one, and area is another parameter. So I'm actually going to assign this parameter to this object. So, or actually, I'm a bit ahead. I'm going to assign them a bit later to the floor slabs, which I'm going to create now. So sorry about that. So, and here comes a functionality which is thinks is very useful, which is we have the levels, we have the volumes, we want to create some floor slabs. And again, I just need to select my volumes. Just for example, I'm going to make this into some kind of office. So we have all the three different kinds of functions there. I'll select them, I'll go to the massing, and we'll start work on kind of cutting the floor plans. You'll see a preview of all the floor plans here. You also see a simple overview of all the different kinds of, you see all the area divide per level and per function. So you can kind of, you can even modify the model as you go. For example, maybe this one wants to get a bit, or actually maybe a bit lower, and we lose a level. It should reflect, and I get less square meters. So if you're happy with this result, you just bake everything, and we get floor slabs. So I'm gonna just do a simple layer operation here. Put them on a separate layer. Just a second. Let's call it floors. All right. So you see that they inherited the parameter values from their hosts, their volumes. And these are the floor slabs we will be using for the next step. I'm gonna just, while I remember it, I'm gonna add those two parameters to the objects. Right. Okay. Next step would be to show a simple example of how we can use the schedules, which is here. Yeah, I'm gonna just make the schedule, and we can actually, while we have the schedule open, we can start editing a bit. So this would be area per function, and I can talk a bit about the things about what the schedules can do. I'm gonna group the columns. I'll talk a bit more about that when you have the schedule open. I'll just quickly create it. I want to create the area schedule and group it by the function, and have for every row in the schedule there will be like one row is one level basically. So save this and open and make this a bit bigger. So we have all the levels I created earlier, and we have all the functions, and you have the area per function in a kind of a nice table. There's also a possibility to sum the area per level. So I'm gonna just go into the settings and sum the areas there, and go back here, and then you could see the square meters per level and per function, and summed in both directions basically. So here is total area for housing, total area for retail, and total office area, and then the total area all together. So the neat thing about this is that it will react to whatever you do while editing the runner model. So you can even hide things. So if I hide this one, it should reflect there, yeah. So it's so you don't have to delete it. So you can kind of edit the model a bit. I'm not going to do too much of editing on this live broadcast, but I can, for example, change this to housing. Go back. Sorry, let's move this one over here and go back to the parameters and change this to housing. And it will calculate, and we got some more housing on the level 5, I guess. I can show again the old one I hid, and then we should get, yes, more housing. So you can, the user can kind of juggle a bit with different functions per level, edit the geometry, hide, show stuff to get to the desired total area. So yes, I mean, just a quick thing is that, yeah, you know, we see the aggregator values here for, as I explained earlier, yeah. So next would be Grasshopper. So we have like all the information that resides, or that's in metrics, whether it's in an object or, you know, the parameter definitions exist in Grasshopper, or like can be accessed in Grasshopper rather. So we have our own tab here. We can access most information from the levels, and for the parameters, you can create parameters, you can list them, you can deconstruct them, and so on. I will show an example soon. And also with schedules, you can at least get all information from schedules. And there's even a bake component here. So I will just show a very, very simple example where we go back to the thing I mentioned earlier about the square meter price. So yes, so I have this drop down with all the parameters existing in a model. I have just a normal collection node, and I will just start by fetching all the geometry again in here. You know, maybe I could do some kind of fancy pipe or something, but I'll just do it manually now. And what I want to do is I want to get the square meter price from these objects. I select the square meter price parameter here. I have the objects. I get the values. They're all 0 at the moment. There's a small, yeah, right. Sorry, I'm not gonna, I'm a bit doing a bit, I'm gonna get the function here to, I'm sorry about that. I'm gonna get the function from them to be able to map the values. And then I'm gonna set square meter price. So sorry about that. So I deconstruct the function parameter, get different categories here. I made a new list myself here, which is just, you know, some kind of yearly square meter prices for the different in our Norwegian currency, kroner. And so I'm gonna, the idea is that I will pipe those, or like assign those values to the objects depending on their function parameter. So do a simple key value search, and yeah, I can show what's coming up there. So there you go. So it should, yeah. This is, there you go. So go on top here, housing to 2,800, and retail on 0.6 there. It's 2002. So you're kind of matching, searching for the values, and then outputting the corresponding prices here. So if I just connect this one here, it should assign everything to all the objects. So this will be housing, it has 2,800, perfect. And then final step, I could create a schedule for this. So see if I get this right. So let's call it, oops, full price, group by level again. Yeah, why not function? And then let's get price here. And then double click, and we should make the landlord happy by showing all that money he can earn it. And there you go. A summary, very simple example of how you could use the parameters and the function categories to create some simple schedule like this. So that kind of that sums up the example. Well, just mention that we also do some. There's some other functions which we have like specially made for Hedwig, which basically you can navigate the levels and you can make sections and also automatically generate drawings from your levels, which is this, I mean, we can kind of customize the tool for the client basically. Yes, and we will launch it hopefully by end of April on Food for Rhino. Follow us on LinkedIn or check out reop.com for updates. And yeah, that's it from me. I'll stop my sharing here. All right.
Thank you for the presentation, Thomas and Fernando. Has been great. I have seen Fernando has been answering the questions in the chat, but if you prefer to answer them now speaking, we can check them.
Someone was asking like, how can you change the different heights of the levels? Because they were saying like in the lower levels you may have a higher height compared to the upper one.
So you can basically by moving the levels. So the editing experience at the moment is by manipulating the levels in the Rhino viewport. So you can just move them up. So you will move, if you want to make a higher ground floor, you just move all the levels above it up a few meters or like whatever height you want. Right. Yes,
I don't know if you prefer to continue, Fernando, with if you have something to comment. If not, well, I shared the link with the example that you sent me, and thank you for sending all the examples and the Grasshopper files. I think a lot of people already downloaded from the comments. I'm checking the last comments about your webpage, that yes, you have reop.com where you can find more information about the plugin also.
Imperials, with Imperial units it works.
Yeah,
we fixed it some months ago.
Yeah, so feet and inches, you got it. You can do that. So there are a lot of questions, but I seem there's a lot of them are already answered.
Yes, Fernando,
useless.
No, that's great.
What's an argument back?
No, but I think it's great because you are answering them in the same comments, so I think it's easier to have them organized.
Yeah.
I don't know if we are missing any of them. What are you?
Maybe.
Yeah, Sheriff is asking if there are some difference between the plugin that you showed and the one that you're going to release.
Yeah, that's a question from the second to last question. Yeah. So there's a few. I think it's quite similar, but it's a few. I mean, it's been polished a bit more. I don't know exactly the feature differences, but there's some new stuff we have been adding.
It's going to be almost the same.
Yeah, basically.
Yeah, okay.
What's for sure is new is I think the Grasshopper components are a bit more polished, for example. All right.
Okay, and Edward Petru is asking are you using attribute user text? Yeah.
Yeah, I'm a bit unsure. So maybe Dimitar, if you have a. We are not storing data in those user texts which you can see in Rhino from the user perspective. Let's see. It's a bit more. It's like it's stored behind, like in the object storage behind, so it's not directly accessible in that way. So if you're referring to the the attribute user text, which is in the properties of the objects, it's not. We don't store it there.
Okay, Dimitar is also answering in the chat.
Yeah.
By the way, for those of you that you were not when I said it, Dimitar is also part of our team.
Yeah.
Yeah, it's Dimitar Reop, so I think it's clear.
Yeah, I
think yes. I mean, it could be a common surname somewhere.
Yeah. Yes. So I was, like Dimitar says, I can't remember the terminology of this storage system we're using, but it's behind the scenes in the API. So.
Okay, user dictionary.
All right. Yeah.
Regarding the IFC, it doesn't. You cannot export the properties in Rhino to IFC yet.
No, you cannot. No.
Okay.
Maybe, I mean, with Rhino inside, you can do something and export them to Revit.
Yeah, if you have an IFC exporter and you could use some Grasshopper or something to pipe the metrics parameters to that.
But we haven't checked it.
No,
ever.
We can't do that at the moment.
Don't get your expectations very high.
I mean, if you could always look into it, but
some request for the future.
No, that's
improvement.
Yeah, I mean.
But yeah, well, I just want to remember that the webinar has been recorded and I will upload it to YouTube tomorrow, and I will also share the link with the files. And if it's, I don't know if there are also some other links like your webpage, the link to metrics, for example, and when the plugin is released, I can also share it.
Yeah, thanks.
And if there is a problem with the samples or anyone needs more information, reach out. Not a problem.
Exactly. Well, as I see, not a lot of more questions. I don't know if you want to add something.
Yeah, just a quick. The model and the Grasshopper script I will add it so people can look at that as well.
Okay, perfect. Then I will update the link and share with that example.
Yeah.
Well, thank you for this presentation and also for sharing all the examples. That is great. I think for people to be able to check the definitions and the examples is very interesting. The webinar has been great. I've been very interested in all the different applications that we are using with Rhino and Grasshopper. So many thanks and have a nice evening.
Same to
see you.
Yeah. Thank you very much for the invitation.
You're welcome.
Thank you very much.
Bye-bye.
Bye-bye.
See you.